Testing? All right. People are trickling in, but I'm just going to launch into it. I'm honored and humbled that so many of you have shown up to the 9 a.m. slot the night after the party. I'm going to try to mumble my way through these prepared remarks, and then anyone who needs to, when this is all over, can go take a nap. But the important thing is that we're going to get through this together. So I want to talk about maintainable JavaScript because I think it's long past time. JavaScript, despite having been around for a while, sort of had a renaissance about, I'd say, 6 years ago, when in the midst of the web standards movement and Google sort of pushing the limits of what we could do with Ajax. And so nearly overnight, it went from being a weird sort of toy that helped you fill out form fields in your internet expenses app to something that we were using for real things and could combine with modern HTML and CSS and try some bold new things in our web apps. For many of us, though, that means that we've been writing JavaScript faster than we've been able to organize it or even decide how it should be organized. I know a bit about this because I consider myself an expert at writing ugly JavaScript. Not to brag or anything, but as a framework author, it might be a bad idea to admit that sometimes frameworks contain ugly code, but I do find myself writing ugly code as a proof of concept and then organizing it later on to get it ready for a public release. It's also true that browser-based frameworks are designed to solve a lot of problems that are inelegant by nature, so sometimes it's better to put that ugliness into a framework rather than expose it to an end user. I also work for Gowalla. As our website grows, our web team writes more and more JavaScript, and I can assure you that most of it is a mess the first time around. We are a startup after all, and rapid deployment is important, and only after we launch something typically do we have time to go back and make it maintainable. So I don't want to make this sound like a lecture, because few of us are in any position to lecture. We all write ugly code. We can only hope to minimize the amount of ugly code we write. So what is it about JavaScript that makes it so prone to ugly use? I think part of it is what I'd call PHP syndrome, in which a language makes itself very easy to learn by hiding new users from anything complicated. In general, I think this is actually a good idea, but it presents some difficulties. The biggest problem is this: a JavaScript code base gets uglier as it grows. I don't think this is a controversial thing to say. In fact, I think I can demonstrate it rather easily. On the first day, everything is fine. You've learned just enough that you can do simple DOM-related tasks with jQuery or your library of choice. You can sprinkle one-liners throughout your code to add targeted polish to your site. All your tasks are simple and straightforward, and someone has already written a blog post about each one. So now we're about 1 month in. Here's some code that we used to have on Gowalla.com, in case you thought I was joking. I've got a collection of spots here, of Gowalla spots that I'm iterating through, and I'm plotting each one on a Google map. And then within that loop, I'm adding an event listener, and in that listener, I'm creating an HTML snippet through string concatenation. And if this were the only JavaScript in my app, this would be fine, but it isn't. Multiply this by about 50, and you're in the middle of a dystopian future where you've got a 4,000 line long JavaScript file, and you're looking for the line that the line that's got the random string of HTML so that you can change a class name. But it gets worse. Let's say this is 3 months in. This is the dark period. This is George Bailey about to jump off the bridge. This is input validation mixed with view state control, mixed with data retrieval. Again, imagine you've redesigned your site, and you've got to go through this code and make it work with an entirely new view layer. Code like this happens because web development contains long periods of incremental changes. Gigantic changes are fewer and farther between, especially at the beginning. And incremental changes are mundane and boring, and we don't like them very much. So we do whatever we have to in order to get them done quickly. We'll copy and paste code from somewhere else. We'll add a new layer of conditionals to handle a weird edge case. We'll add an extra line to a complicated event handler instead of, when we really should be rewriting that thing in the first place. So as a result, our JavaScript code base gets ugly at an accelerating pace. Again, this happens because architecture, in general, however you want to define it, is inhibiting when you've got 100 lines of code. But it's essential when you've got 2,500 lines of code. So somewhere in between, before this line starts to get too steep, in the middle of all those incremental changes, someone has got to say, okay, stop. We're going to rewrite this stuff before it gets too unmanageable. In practice, this usually doesn't happen until we're well into gremlin territory. So I'm going to try to offer some advice for getting out of the weeds based on my own experience and the wisdom I've gleaned from others in the JavaScript community. I don't want to get into design patterns because I think that's a bit too granular. And I also don't want to endorse a specific stack of frameworks as the answer to all of your questions. At least at first, I'd rather just talk about the ideas, describe the course of action I think you should take, and hopefully I'll convince you that it's a good plan. You might find that parts of my advice are obvious to you, but I've found that different parts are obvious to different people, so I'm going to just put it all out there. It's important to keep in mind that we'll be applying existing wisdom to this problem. We don't need to develop radical new theories of architecture for web apps. So to chart out a plan of attack, let's start from the end and work backwards. What are we trying to solve? What do we want from our code base that we don't have yet? We want modularity, which means several things. First of all, it means that tasks are divided into modules that are separate and distinct from one another, hopefully preventing the scenario where you stare at 10 lines of a gigantic file and can't figure out what they're for or what they belong to. Secondly, it means that the modules are organized by purpose, which we'll get into in a second. Third, it means that there's a single point of modification whenever you need to change how that code behaves. If we're repeating ourselves, if we're copying and pasting code, it means we're usually doing it wrong. Next, we should be able to make changes safely. The virtues of interchangeable parts apply just as much to software as to manufacturing. I should be able to change the component's implementation details easily, as long as I don't change the way it talks to other components. Or failing that, if I change the way it talks to other components, I should be able to verify that it's only those components that will need changing and not unrelated things. Finally, troubleshooting should be as easy as possible, as easy as troubleshooting can be, which is important because most of us have had to troubleshoot code we didn't write in the first place. Or failing that, remember Eagleson's law. Code that you wrote more than 6 months ago might as well have been written by someone else. So when we look at a page, either in our source code or through view source in a browser, we need to be able to tell what's happening on that page, which components are being used, which event listeners have been hooked up, and so on. Even if the code is unfamiliar to us, we shouldn't have to step through code in a debugger just to decipher it. So having decided that these are good goals, we've got to implement them. But let's, if we tried to start right now, we'd spend a lot of time staring at an empty code window. So let's look at them again and sort of figure out what their implications are. First, how should we divide our code into modules? The obvious approach would be to put each piece into its own file. So this means we'll need some sort of build system to concatenate the JavaScript before it gets to the user, but that's okay. The virtues of separate files in development are important enough to make that worth it. It saves us from monstrous JS files that are impossible to navigate. But what is a component in practice? Where do we draw the boundaries between them? We can take a cue from our second wish. If we want to be able to rewrite a certain component without affecting other things, then it follows that a component should be large enough to hide its implementation details from other code. This implies the idea of public and private parts of a module. The public parts are the parts that are dependent on by other modules, and the private parts are really everything else. Or in other words, a component is the smallest practical unit that you can envision replacing by itself. This is a bit of a fuzzy definition because there are no good rules here. You can't, for instance, pronounce that anything smaller than 20 lines of code is too small to be its own component. for the same reason that spark plugs are separate from a car engine. I like that I can replace them without replacing my engine. The law of Demeter is a simple idea that really can be twisted to support anyone's argument, so I'm going to twist it to support mine. A unit should minimize the extent to which it relies on other units. The more it talks to other units, the more assumptions it makes about those units' behavior, which means the more brittle it is as those other units change their behavior. So it's an argument for simplicity of design, the same way you'd want to design a machine so that individual parts connect together in the simplest possible way. So that's another way of looking at it. Components should be written so that they don't reference any other components they don't need to. That in itself, I think, is a good rule for dictating both size and scope of components. I can give you a few examples from Gowala's own code base. So we've got a module called gowala.location that manages all client-side geolocation. There are a few places on our website where we try to guess where the user is for usability purposes, and so it behooves us to centralize that detection logic. At first, this was a multi-tiered strategy. We used HTML5 geolocation, if the browser supported it, and then fell back to Google's IP-based geolocation. We quickly learned, though, that people aren't wild about that permission dialog that pops up in a browser asking them to share their location. So we changed it to use just the IP-based geolocation, which was accurate enough for our purposes. But it meant that this was easy to do because there was a single point of modification. Our activity feeds are another example. We've got Twitter-style timelines of user activity on a few different pages. A user's page has a list of their check-ins. A spot page has a list of check-ins at that spot, and so on. And so we've got one module that handles common functionality for all those feeds, inline commenting on check-ins, AJAX pagination, and polling for new items. Here's a simple one. So we've got a gowala.flash module using the Rails terminology where flash message is a transient success error message. Gowala.map is a bit more complex than that. There are several places on our site where we need to take a group of Gowala spots and plot them on a map. We noticed we were duplicating large amounts of code simply because each of these cases had slightly different requirements for behavior. So first we moved that logic into its own module, and we gave it methods like add spot that abstracted the process of adding a spot to a map. In this case, that spot argument is some sort of deserialized representation of a spot that has like a latitude property, a longitude property, and a name. And then we gave that method an optional second argument that allows us to customize the way the spot appears on the map. For instance, if I want the marker to show a spot description when clicked, I can pass in an option that supersedes the method's default behavior. By the way, this pattern is used all over the place in JavaScript frameworks. The best way, in my opinion, to balance simplicity and configurability is to pick intelligent defaults, but allow for those defaults to be overridden. And so I urge you to look through, say, jQuery UI source code or prototype source code to see some good examples of this pattern. Moving all our map-related tasks into one module helped in unexpected ways, too. When we wanted to upgrade to version 3 of the Google Maps API, it turned out to be a simple task because I just needed to write a version 3 implementation of this module. And by looking at the existing code for the module, I knew exactly what map-related functionality we were already using. I didn't have to search our entire code base for random map drawing method calls. It also meant we were able to move to version 3 gradually. For a while, the two different implementations of gowala.map, one for version 2 and one for version 3 of the Google API, existed side by side, and each page picked the one it needed based on which version of the API we'd loaded on that page. Luckily, the transitional period was short. This also means that if we wanted to, in the future, we could move to an entirely different map provider. If we wanted to move to Bing Maps, or if we wanted to just roll our own thing and do some sort of OpenStreetMaps implementation with custom tiles. We can do that rather easily without affecting any of the individual pages. Anyway, back to our second wish. If I want a component to be modular, I need to know which parts of it are relied on by other components so that I can keep those parts constant. I need to standardize the points of communication. My favorite way of doing this is through a message bus. Rather than require two modules to talk to each other, I can tell a component to broadcast certain messages that anyone can listen to. It sets up a publisher-subscriber relationship where the publisher tells a central object to announce something along with any related metadata. I'm going to call this custom events for short because that's how most frameworks implement it. This approach, I think, has a few advantages. First, the publisher doesn't need to know anything about the subscriber. The publisher only needs to know about the broker object that handles the broadcasting. This is a clever way around the law of Demeter. Components don't need to know about one another. They just need to know about that broker object. The publisher tells the broker to trigger an event. The subscriber binds itself to that event. Second, the broker itself, not the publisher, handles the boring details of notifying interested parties. So the publisher doesn't have to keep an array of callback functions or worry about the order in which it fires those functions, or it doesn't need to worry about recovering gracefully if one of those callbacks throws an exception. Third, the broadcasts can easily be heard by anyone, which makes it easy to eavesdrop for debugging purposes. We'll talk more about custom events in a second. But our third wish was for easy troubleshooting. Aside from what we've already discussed, the best approach, I think, is to embrace conventions. Conventions are just predetermined ways of doing things. They're great because they don't require much debate. The important thing is to pick something and standardize on it, even if it's arbitrary. So you might decide that a component called goala.location should live in a file called location.js in a folder called goala. Or you might decide the component should have an init method or setup or load or something that for any setup they need on page load. Presumably, you prefer conventions that seem broadly intuitive. But the most important thing is that they're easy to remember and easy to teach to new developers. They should be reflexive and not the sort of thing that you have to look up. All right, so coming back to custom events. First of all, no matter what framework you're using, it's probably got an implementation of custom events. So here's jQuery's version. And it involves a trigger method, and the second argument is optional. It's an array of extra data, and all the items in that array will get passed through to the event handler's extra arguments. Prototype's version is similar. You've got a fire method and a second argument for metadata, which is attached to the event object as the memo property. Dojo's implementation is the odd one out, but probably the purest one architecturally, because it doesn't use the DOM infrastructure. They call it pub/sub, but the ideas are similar. When firing a custom event, you decide what it's called, and you decide what data will be attached to it. And these two decisions create an implicit contract between publisher and subscriber, and that's the part that you're going to standardize. Once you've done that, you're able to change anything you want about either the publisher or the subscriber. You might be thinking that this sounds like bizarre, impractical advice shouted from an ivory tower. I'm not saying that all communication should take place through events. To revisit the law of Demeter, the purpose is to remove unnecessary coupling from your code. Some coupling is necessary. To use the map example we saw earlier, if I'm writing a module that adds spots to a map, obviously it's going to need to know about my goala.map module, and it's going to need to know about the add spot method. There's not much we can do about that. There's no reason that we need to replace that with a custom event. That's a necessary coupling. On the other hand, there's no reason why goala.map must know anything about a module that's using it. In fact, the less it knows about those modules, the better. It's supposed to be generalized. So here's an example from Scriptaculous 2.0. It's got an autocompleter control, a text box that suggests possible values after you start typing. Architecturally, it consists of an autocompleter class that acts as a manager for a generalized menu class. The menu is a separate component because there are several different places where we'd want that kind of behavior, drop-down menus and that sort of thing. And so we want to make the behavior uniform. So the autocompleter talks to the menu by declaring a new instance and then calling methods on that instance. And the API is pretty simple. So here we're creating a new one. We're adding a couple of choices. We are appending it to the DOM, and we're telling it to open. Then it listens for specific custom events that are fired by the menu, like the one here that occurs when a user chooses a menu option. There is no code in the menu class that knows anything about the autocompleter. All it knows is that it's going to fire events when certain things happen, and it's the job of the managing class to coordinate its responses to those events. I could spend another half hour on custom events, but I'm going to move on for now. I know I've been dealing mostly in the abstract, so I'll give a couple examples of what a code rewrite should look like up close. In this bit of ugly code, we're asking a URL for some JSON, and once we get it, we're building HTML from it and stuffing it onto the page. I would prefer to split this code up into two different tasks, one for requesting the JSON and one for turning the JSON into HTML, which means we could do something like this. We could make the same AJAX request but have it fire an event when it's complete. So you'll notice all I've done there is change the success callback from one that renders the HTML to one that just fires the event. And then on the other side, I'd have a method to render the data as HTML, and I'd make it listen for that custom event. This might look ridiculous to you because it's hard to demonstrate custom events with simple examples, the kind that can fit on slides. And this specific example is more reminiscent of communication within a module than communication between modules. So instead, you might want to do something like this. Rather than fire the custom event, you'd have this, which retains the basic idea of separating the data retrieval from the rendering, but which names the render method specifically in the AJAX callback. Both approaches address the need to organize code within modules. Spaghetti code happens when concerns are mixed together. So you'll want to organize code so that all the rendering code in a module lives together, all the input validation code in a module lives together, and so on. In other words, you should be organizing code into modules, but also within the modules themselves. In doing that, you've made it explicitly clear what the only obligation is for any code rewrite. If you're redoing the content retrieval side of it, for instance, you know that your job is to call a render method and give it the spot data, and everything else is just an implementation detail. You've also made it far easier to unit test your code. Yes, unit test your code. It's not just for libraries, it's for your code too, and it's easier to do than you think. The view rendering code isn't stuffed in some random anonymous function inside a call to $.AJAX. It's got a name, so we can test it without having to mock out anything to do with AJAX. You don't even need to run your app server for this one. All you need to do is get some fixture data and pass it in, and then ensure the code behaved the way you expected. I've tried to keep this advice abstract so that it's relevant to most of the people in the room, but some of you probably need more targeted solutions. In particular, I'm thinking about desktop-like web apps, which we occasionally call single-page apps because they throw out the page-based model and do all of their client-server communication through AJAX. Gmail, for instance, contained 443,000 lines of code as of about a year ago. So I imagine they've got strict architectural principles in place for that. So there are a few traits that many single-page apps share. Many of them have some sort of object mapping for keeping track of data on the client side. As a result, the server becomes the place where changes are stored. And so many of them end up having to define a way of synchronizing data between client and server. Very often there's a one-to-one correlation between these data objects and on-screen views, which implies some way of mapping objects to views and ensuring that changes to those objects trigger changes in the views. And many of them also try to make the back and forward buttons useful, using them to control application state. That means they're changing the URL hash, or they're using HTML5 history management and changing the whole URL. And it means they have some sort of system in place for monitoring changes to the hash and loading other states, some sort of router. So we can call this whatever we like, but the three things I've just described are models, views, and controllers. So it's not a surprise that most JavaScript frameworks aimed at single-page apps use the MVC terminology. The principles are all the same, so I'm going to demonstrate them using Backbone. Backbone is about 6 months old, but it's got quite a bit of traction. I like recommending it because it's a lightweight implementation of MVC-type principles. It's also easy to use only parts of Backbone. If all you need is URL routing, for instance, you can use only the routing parts, which don't depend on any of the other parts of Backbone to work as advertised. And the whole library, minified and gzipped, is about 4K, so it's not at all wasteful to leave some features unused. The code on the next few slides is a simplified version of Backbone's sample application, which is a to-do list. You can define a model object of a certain type by extending the base backbone.model class. Model objects can have any number of properties. They also implement a few methods. An initialize method that gets called whenever a new data object is created. A save method that is called to store any changes, and so on. You'll notice that some of our property access is wrapped in get and set methods. This allows Backbone to fire events when properties change. Keep that in mind for the next slide. We've also got a validate method, which gets called implicitly when we try to save an object. By default, this is an empty method, but you can override it and define whatever custom validation logic you need. Backbone views are, in turn, subclasses of backbone.view. A view object has a one-to-one mapping with an HTML element. You'll notice a few conventions here. Tag name lets us specify the HTML element we're using. The default is div. The events property is an object of key value pairs where the keys specify events and the selectors they should apply to. And the values name the methods that should get triggered. So for instance, when a user double clicks a div inside this view that has a class name of to-do content, Backbone is going to call this view's edit method. You'll also notice that there's a mapping to a model object. We specify that model object when we create the view. And because we use those set and get methods inside the model, any property changes on the data object will trigger a change event that the view object listens to. Here, we're calling the render method on any model changes. By convention, that's the method that sets the contents of the view's HTML element. Backbone has built-in synchronization as well. By default, when a model object is changed, Backbone calls the backbone.sync method to tell the server about the changes. The code on the screen is a simplified version of the default backbone.sync method. You don't call this directly. It gets called implicitly when you change model objects. And it receives 4 arguments: the type of action, whether we've created something or deleted it or changed it, and so on. The model object, and 2 callbacks, one for success and one for failure. And you can see how simple it is. It figures out which URL should know about the change, figures out the HTTP verb to use, get, post, put, or delete. It serializes the model object to JSON and it sends it to the server via AJAX. But you can override syncing behavior either globally or locally on a per model basis. For instance, you could make it so that changes to model objects synchronize in batches rather than one at a time. Or you could tell it not to talk to the server at all. The sample to-do app changes backbone.sync to use HTML5 local storage instead, which means that it doesn't need a server at all. There are other excellent options as well. The biggest difference between Backbone and the others is that Backbone is simple enough to put on slides, so it's a good way to illustrate these principles. But you might want something larger and more feature-packed. Sprout Core and Cappuccino are both efforts to port OS X's Cocoa API to JavaScript. If you're familiar with Cocoa and you like the concepts behind it, I urge you to investigate both because they're faithful translations of the Cocoa philosophy to a browser environment. JavaScript MVC is another popular project that gives you MVC-ish tools in a way that builds a top jQuery and preserves a jQuery-ish sort of API style. So I've named 4 MVC-ish frameworks for JavaScript, and there are a half dozen more I could name. I can't recommend any one of them over the others. When people ask me, should I use jQuery or Dojo or Prototype or MooTools, I say, I don't know. Try them all, give each one a few hours, and pick the one that makes the most sense to you. So that's the advice I have for you if you're trying to decide between these and other excellent frameworks. One of them is going to agree with your brain. Use that one. I should mention one final thing. Having decided that you're going to change your ways, you might be tempted to wipe the slate clean and start over. Please don't do this. If you're anything like me, I can assure you you'll get halfway through, hit a rough patch, put the project aside for a few days, and forget all about it. And even if you do manage to rewrite everything, there's no faster way to annoy your coworkers than to swap code out from under them. Hey, Bob, you know that part of the app that you own, I rewrote it, and it's now much better. You're welcome. It doesn't really go over too well. In my experience, I've only been able to do a total code rewrite when I start slowly and rewrite things incrementally. You can save the clean room coding for those times when you need to write something from scratch anyway, like when you're developing a new page. But for your existing code, it's better to improve it slowly and surely. So if you need to change something in a concatenated HTML string deep inside some rarely touched file, I say make the most of the time that you spend there and convert that string into something more readable in your templating library of choice. By the way, you might have noticed that I haven't talked at all about templating, and that's intentional. I really don't want to wander into that minefield of opinion. Again, there are about a dozen libraries, and all of them are fantastic, and use the one that makes the most sense to you. Keeping a dirt-free code base is no easier than keeping a dirt-free house. There's a small handful of really annoying people who make it seem effortless. For most of us, it's a constant struggle, and perfectionism is an impossibly high standard. The goal is to have something sustainable, something we can stick with for the long haul. Some of us make New Year's resolutions about code, as like, you know, the same way that we'd make a resolution to exercise more and then spend 2 consecutive Saturdays flailing on a weight machine and then decide it's too hard and never do it again. Do not treat code maintainability like a New Year's resolution. Except that there will usually be some small amount of ugly code in your source tree. But make sure that all of your code trends toward maintainability. So we have an obscene amount of time for questions. Step on up to the mic if you've got one.
So in your example, you used going and getting some JavaScript data from the server and then rendering that with like building HTML on the client with it. How would you weight the approach of generating your HTML on the server and just injecting it on the page versus getting your data from the server and building the HTML on the page?
That's a tough one to generalize because it depends on the opinions you have about the view layer. And I mean, those two approaches I think are just different weightings of concerns. If you've got a situation where you're doing rendering on the client side, then either you're going all the way and doing all of your rendering on the client side, or you've got a situation where you've got some client-side templates and some server-side templates. Some people find that okay to have some HTML that's generated on the server and some that's generated on the client. And that doesn't bother me personally. That doesn't bother me too much as long as for any given thing that's being rendered, there's just one thing that there's just one place where it's rendered, whether it's the server or the client. In other words, as long as I don't have to maintain two different templates and keep them in sync, then it works. It works for me. That's the reason why some people choose a templating library that can work on the server and the client, because for some people that's a specialized concern, but it's something that some people feel very strongly about. I'm going to ramble my way toward an answer here. So I think it depends upon what's important to you in terms of view templates. Whether you want whether you want all the rendering to happen either on the server or the client, or whether it's okay if there's some of both. To use GitHub as a high-profile example, they're doing really interesting things with what they call PJAX, which is partial page replacement through Ajax, which is great because it layers onto it layers on top of standard sort of page-based model. But so, for example, when you're browsing a source tree in GitHub and you click on a directory, it replaces only part of the page, and then it swaps the URL out through HTML5 history API. And so what you end up with is the same page that you would have gotten if you requested the whole thing, but it's giving you only the part that changes. To me, that's a really good reason to say we're going to send HTML over the wire, even though it might be a bit more verbose than sending the JSON and having it rendered on the client side. I also mentioned it because I think it pushes back against the trend, because I think we all sort of started out just sending HTML over the wire, and over time people are more and more just sending JSON over the wire. So yeah, it's hard to recommend something that applies to every use case, but yeah, I think you should. I think it depends on what you think is important for your view layer.
Thanks.
I have a question about physical storage of your JavaScript files or anything like that. The code often is more maintainable if you split each of these modules into sort of separate files. But if you put each module in a separate file, it can make your web app perform very poorly because you have to have separate web requests for every thing. Are there any good ways of managing how those get merged together, or if they should be merged together, anything like that?
Sure. So the question was about dealing with the fact that when you split your code into files, you've then got a bunch of HTTP requests to make. What you'd want to do is have them put them in separate files for development, but for in production they would all be concatenated together. There are several tools that will do that. Gowalla uses Sprockets because it's a Rails app, and Sprockets is good because it's when in development mode, it's sort of a specialized like URL route that when you request some file that represents the concatenated version of all your JavaScript, and it sits there and it takes all of your files and assembles them in the order that you've specified and delivers that as one package. And this works in development because it knows when it needs to update that concatenation based on the last modified times of all your files. And then in production, you can define some sort of deploy time task that assembles it all together and does whatever other transformation you want. Like it can minify it at that time, run it through compressor, have a pre-gzipped version of it, whatever. So that's what I recommend.
Thank you.
Hi. When working with a graphic designer, do you have a convention to kind of separate visual style selectors versus functional selectors in the structure of your document? You know what I'm talking about?
Yeah. That's an excellent point. I think I have learned the hard way that it's better to, even if it involves adding an extra class name to a button, I think it's worth it to have that extra class name just so that you can be sure that class name is going to be there even when the design of the button changes. If I understood what you're asking correctly.
Yeah, that's exactly right. I was wondering if you were using like a naming convention, a suffix system, or something to basically tell the designer, hey, here's the prototype. Anything that starts with that, don't touch it.
In Goala's case, it's a bit more ad hoc. Luckily, we don't have enough HTML yet that we've needed to put conventions in place for that. But having had to go through our code base and do a mass find and replace, like changing a.button to a.btn or something like that. Yeah, I've started to add extra class names to certain elements that are explicitly meant just for JavaScript and not for styling. Mm-hmm. So yeah, I would recommend that.
Okay, thanks.
So there are certain pieces of a code base, such as validation, that kind of get sprinkled throughout your different components. And obviously there are frameworks that are devoted to validation. Do you find that it's better to use these specific frameworks and then to take a dependency throughout your application on these frameworks, or do you, for maintaining your applications, do you kind of write your own, or are there any gotchas in those areas that you found?
For the standard sort of for input validation, mm-hmm. In my experience, I've never worked with something that had enough validation that I found using a library, like using a specific validation library, saved me time over just writing it myself. I don't I hesitate to recommend that for everyone, but I find that especially in sort of a page-based app, when what you're doing is sort of a pre-screening of the input, and because the server is going to validate that data anyway, this client-side validation, of course, isn't a replacement for server-side validation. That all the validation I've had to do is lightweight enough that that I haven't needed to offload that onto a library. If you're doing really specific types of validation, like input masking, like if you want to feel that enforces that there can only be an email address here, or only like a phone number style thing where you only allow digits and hyphens, then I think that's the sort of place where a validation framework works best. But otherwise, I personally would not bother with it.
Since I'm alone up here, I'll ask a second question.
Excellent. You're free to make your second question last 15 minutes.
Excellent. So have you had any experience with script loading frameworks like LabJS or Require.js or any of those, and do they have any impacts on the way that you maintain your JavaScript?
I know a lot about LabJS because I know Getify in person, and he won't shut up about it because that's the kind of guy he is. But I wouldn't shut up about it either because it's legitimately pretty awesome. It solves a use case that I have not yet had. I haven't yet gotten to a point in an application I've worked on where a piecemeal loading of scripts had an advantage over just throwing everything into one file. You know, the advantage there, of course, is theoretically a page performance thing to minimize the number of HTTP requests. But the approach to something like LabJS, I think, would be excellent if you had some sort of app where for example, if you were conditionally loading certain scripts based on capability detection. So, like, if you had a piece of functionality in your app that used WebSockets, if the browser supported it, and then fell back to like an AJAX polling type thing if the browser didn't, then there are use cases where you would load one script or another conditionally, and then have a callback set up to fire when it's done loading. The script loaders is another area where there's about a half dozen really good solutions. I would recommend LabJS without hesitation, just because it's the one that I'm most familiar with. But you can, and I'm pretty sure I've seen a feature matrix like in the last month or so where someone put like dedicated a column to like each of 6 different script loaders, and you know, you can look at something like that and figure out what your specific needs are.
Thanks.
Hey, I'll ask another question. If you have time.
Your question can be 11 minutes long.
All right. You briefly mentioned unit testing your JavaScript.
Yes.
And I know there's a number of frameworks out there to do that, but what framework or approach would you recommend for unit testing, and what kind of assertions do you typically make in your JavaScript unit tests?
I would use whatever framework. I don't know. There's sort of a canonical testing framework for each browser framework that you use, except for jQuery, because everyone uses jQuery, so there's you know, there are a lot that you can choose from. You can pick something like QUnit, which jQuery uses, or you can pick let's see, Prototype uses Test Unit, which is like a direct port of Ruby's testing library. The assertions that you would make, of course, they depend on what you're testing. If you're testing view layer stuff, I find it's very, very useful to render stuff, and then you've got the power of the whole selector engine of your framework of choice to assert that there are certain numbers of items that conform to some selector. So like an example, you know, we rendered a few list items and then tried, you know, to select LIs that were like direct children of our container, and verified that there were a certain number of them. If you're if you're testing something else on the client side, like data models or something else, whatever framework you've picked will hopefully make it so that you can focus on focus on a high enough level of testing so that like you're not testing really sort of granular implementation details type things. For example, if you're using backbone models, you could create a model, change something about it, try to save it, and assert that an exception was raised because it didn't pass validation, that sort of thing. There's a testing approach which I don't really see the point of that tries to be very, very specific with everything, that will make a method stub and then write a test that calls that method and then asserts that method was called. I think I don't know. You can sense my prejudice, but I think it ends up being a sort of circular thing where you end up having to change your tests almost as often as you change the implementation. And so, I don't know. I think the best advice I could give would be to make your tests just make your tests read like a spec, but have them not get unnecessarily specific. Does that help?
Yeah, yeah. So kind of like more like integration tests even. Would you even like call back to the let your AJAX methods call back to the server, or maybe that depends on your situation and what you want to test?
Well, I am a fan of integration testing, but I've found that like if you're doing integration testing, that's the sort of thing that you'd want to launch the whole server anyway. Integration testing happens, at least so like on Rails, testing happens in Ruby. So you're talking about a level of testing where you're just testing the individual units, where you could take each of those modules in turn and do some limited amount of testing with them, and then. It's often a good idea to have some level of integration testing, either as a sanity check or to test the parts that can't really be captured in unit tests. That, in my experience, that typically takes the form of, create a new account and try to go to a page that's only for super users and make sure that that new user can't get to that page. That's the level of specificity that I see most often in integration tests.
Thanks.
Sure. Does anyone have a 6-minute question? If not, we're done.